Hey guys, let's go over the Integrated Math 3 quiz number 9, 2.11 to 2.12, February 4, 2020, which is a factor of 3x cubed plus 5x squared minus 27x minus 45. A couple of things that you should be doing here. You should be counting the number of terms. 1, 2, 3, 4. On your flow chart, this would mean you would have to do factoring by grouping. Remember, there's two ways of kind of doing this problem. I'll show you guys first the double GCF. Here in blue, my common factor here is an x squared. And I'm left with 3x plus 5. Remember, you can always distribute your answer to double check your answer above. And then over here, let's use a green. Here in green, if you take the GCF, you can do something like a minus 9. Negative 9 times 3x gives me negative 27x, and negative 9 plus 5 is negative 45. That's the first GCF. The second GCF is this. They both have a 3x plus 5. And then you're left with the x squared minus 9 there in blue and green. This one factors again. A times c is negative 9, b is 0, so it would be 3 and negative 3. And then 3x plus 5. So this is a factor, this is a factor, and this one's a factor, and this one's not. Okay, how would you do that problem? So let's just call that one 2 GCFs. How would you do that using a different method? This is called the box method for the factor by grouping. So I'm going to put inside the box, and we talked about putting it into a z. So that would be 3x cubed plus 5x squared minus 27x minus 45. And I take the greatest common factor going this direction. I believe it is a 3x. GCF going in this direction. Let's do a positive 5. GCF going in this direction would be an x squared. And in this direction, it would be a minus 9. So essentially, you would get a 3x plus 5 and a x squared minus 9. And then you get 3x plus 5, x plus 3, x minus 3. And that would be the same answer as the other one above. Okay? Question number 2. Given p of x equals x cubed plus 4x squared minus 3x plus 2, and p of x over x minus 1 equals x squared plus 5x plus 2 with a remainder of R4. Which statement is true? Okay. So a couple of things here. They took, I'm going to do by colors, this function called p of x, and this is the big idea. What math operation is this? Well, this is division. And basically what we're trying to do is find the remainder. So let me highlight that. This R here means the remainder. Well, how do you find the remainder? You can find it by method number 1. You can use synthetic division. Method 2, you can use long division, or method 3, you can use something called the remainder theorem. And I think this one is the easiest for this problem. Basically what you're doing is you're taking this and you're taking the factor and setting it equal to 0. And if you solve here, you have x equals 1. Okay, what do we do with this x equals 1? Too big. You could take the x equals 1 and basically put it back into the function. Well, they already told us what would happen if you did that. They're saying if you put that in this number into the function, your result is a your result is a 4. So P of 1 equals 4. And is that one of our choices? That is. You can see that this x equals 1 is here. But this one has negative 1, which would be wrong. Okay, so parts C and D. Now it does say select all that apply. And if you look at C and D, they both are showing us how the divisor times the quotient plus the remainder equals the dividend. Okay, so what do you do with a remainder? If the remainder is 4, the remainder becomes the numerator. Remainder equals the numerator, the top of the fraction. The divisor is here in dark blue, or cyan, goes at the denominator. Divisor is equal to the denominator. Okay, that's why C is wrong and D is correct. So in this one, you would have to get 2 of those. Okay, let's go on to the next one, which is basically the same thing we were talking about. When 3x cubed plus 11x squared minus 3x minus 12 is divided by x plus 3, the result is 3x squared plus 2x minus 9 with 15 left over. Complete the expression that represents a true relationship between the polynomials. All right, so a little bit hard because I have to keep moving it down, but that original expression is here. And this is your dividend. So I would write that here. That's what I would drag here. And then the second part is, well, what would happen? And it tells us is divided by x plus 3. So I'm going to have x plus 3 here. So x plus 3. This would be the divisor. So if I was setting this up, let's just say you really wanted to do the problem. Dividend goes inside. And then it says the result is the quotient. So 3x, this is my quotient. This is what would go up here. We'll practice this quite a bit on the your skills practice. And then it says 15 is left over. So the 15 that's left over, okay, here's the tricky part. It's got to be 15 over x plus 3. Let me double check that. Yeah. So that would be the correct answer here. All right, question number 4. Which of the following is a factor of the polynomial? Okay, here's the tricky part. In the previous problem, they would usually give you a divisor, something to start with. They're saying in this polynomial, let's just draw a quick sketch, 8, and it's cubic, so I don't know, something might look like this. We don't know, right? But what I'm trying to say is they didn't give us a starting point. They didn't give us a dark blue spot. Okay, so the question is, which one of these is a factor? A factor, as you remember in the factor theorem, this is what the question is kind of testing. The factor theorem says, yes, it's a factor if your remainder is equal to 0. So if I plug in each one of those into a calculator and find that your remainder is 0, then that's the one. All right, let me show you guys how to do this on a calculator. You can, of course, do it by hand. I'll just show you really quickly one by hand. So x plus 3 is a factor. It's a question, is this a factor? I'm setting equal to 0, so x equals negative 3. Basically, I would be putting in negative 3 in for every x value. It would look like this. And then here, I'm going to be using my PEMDAS. Just do this by hand. So negative 3 to the third power is negative 27. Negative 3 squared is positive 9, positive 30, and then plus 8. So plus 3 equals 18. So the question is this a factor? The answer would be, for this one, no. Why? Because at, say, negative 3, the graph is up here at 18. Does that make sense? It's not crossing the x-axis. All right, let's prove this to you by using calculator. I use something called Graph in Calc 83 for my iPad, free. Let's punch it in. XXX, that's x cubed, plus XX minus 10x plus 8. Okay, and what I'm going to do is I'm going to change my table set. So I'm going to press second table set. I want it to start at 1, and then we're going to have auto. Sure. So now I'm going to press table, and we just put in x equals negative 3. So if you scroll down here, uh-oh, we made a mistake. It says 20 is my answer. Do you guys see that? What did we do wrong? Plus x squared minus 10x plus 8. Uh-oh, our work is wrong. Let's check. Can you see it? Oh, I can't add. I see it. Negative 27 plus 30 gives me a positive 3. Positive 3 plus 17 is 20. Okay. Duh, Mr. Eng, come on. All right, so table. So negative 3, 20. X plus 2 is a factor, is x equals negative 2. So if I go negative 2, I get 24. If x minus 2 set equal to 0, that means x equals 2. that is 0. That's good. And then x minus 3 is x equals positive 3, and that equals 14. So let me take a picture of that really quickly. So what was I saying? I was saying, okay, so if you did this one is negative 2, and then when you put in negative 2 into your function, we said that equals 24. So no, it's not a factor. This one, same thing. This becomes x equals 2. You put in 2, and we said that you would get 0. So that is a yes. And just to double check, I always, for multiple choice, do every single problem. Add 3 to both sides, x equals 3, and when you put in 3, you will get 14. And is that equal to 0? The answer is no. So the answer would be C. Whoa, whoa, whoa. That one doesn't do. Let's try that again. Better. Okay. Let's go to question number 5. All right, question number 5 says use synthetic division to find the quotient when, let's write this down, 3x cubed minus 13x squared plus 2x minus 5. Okay. To use synthetic division, I'm just going to be using the coefficients. So that would be 3, negative 13, positive 2, and negative 5. Okay, then I'm going to make my division symbol, and remember, x minus 4 becomes x equals 4. So I'm going to be using that 4 there. So now I'm showing you guys synthetic division here. Let's get another color here. How about yellow? So we're going to bring down the first one, that gives you 3. Then you're going to multiply diagonal, that would be 12. You're going to add down, so negative 13 plus 12 is negative 1. Then you're going to multiply diagonally. 4 times the negative 1 is negative 4. Then 2 plus negative 4, or 2 minus 4, is negative 2. 4 times negative 2 is negative 8. And if I add down, that is negative 13. Remember, this is our remainder. And the question asks us, indicate only the quotient without the remainder. So what does this pink box represent? What it's actually done, it's reduced the degree. So that means if we started with a power 3, this is now a power of 2. And then you just go down from there, negative 1x minus 2. So use synthetic division to find the quotient when 3x cubed minus 13x squared plus 2x minus 5 is divided by x minus 4. Indicate only the quotient without the remainder. So I'm just going to write down the blue. So let's write that down. Or just negative x, and double check the answer here. Awesome. And question number 6, factor completely. Okay, you should be counting the number of terms if you take out the greatest common factor. There is no greatest common factor between 27 and 125, so I have 2 terms here. And if you only have two terms, you're thinking, is it the difference of squares? So put out my options here. Difference of squares. Or is it the sum and difference of cubes? I'll just call this difference of cubes or sum of cubes. Which one of these? Well, obviously I see a power of 3, so I'm going to be using one of these and not this one. Because another way to explain the difference of squares is if you take half of 3 is 1.5. So do you have something like, would you put that placeholder there? It wouldn't go well. Does that make sense? So you're not going to do that. Okay. Okay, so what do you do for this problem? You're going to have to take the cube root and find an a and a b value. So the cube root of 27 is 3 times 3 times 3, x times x times x. You need 3 of them, so that's 1, 2. So that means a is equal to 3x. And let's go ahead and do that for this one over here. So the cube root of 125 is 5 times 5 times 5. That is the 3 of them, so that would be b equals 5. We're going to just write down the formula from your formula sheet. So in this case, this is a minus b cubed. This would be, let's write this out, same, opposite, always positive. So same is this one. Opposite of negative is plus and always positive. Let's just fill this in. A squared plus AB plus B squared. And specifically, this is called the difference of cubes. Why? Because this is a negative sign there. Now we're just going to substitute each of our values. So a equals 3x. So I'm going to put that here, here, and here. Let's go ahead and do that. Whoops, can't write with the highlighter. So 3x. And then we said that your b value is 5. So every b value is going to be 5. Right there. So 5 parentheses 5. I should have put parentheses for all of those. That is my bad. Okay, let's go ahead and just clean that up, and then let's go ahead and clean this up. So I have 3x minus 5. 3x times 3x is 9x squared plus 15x plus 25. And this would be our answer. Let's write that in there. So again, this trinomial here is prime. You can try, but you can't factor it again. And that would be our answer and our last question to our quiz. So we're now trying to figure out starting points for our polynomial. You can use division, factor theorem, remainder theorem, and that's it. See you guys.